Good afternoon, students. Today we will be starting a new unit, that is the memory organization in computer organization and architecture subject. So in this unit we will see in the system design how we organize the various types of the memory. In next slide we will see that what are the different type of memories and how the memory is organized into the system so to provide system its maximum efficiency. So now we will discuss what are the different contents we will cover in this our unit. We will discuss about the memory. We will discuss about the hierarchy. Hierarchy means how different types of memories such as main memory, uh, our cache memory, hard drive, and the auxiliary memories arranged in the system to make the performance of the system enhanced or improved. Then we will talk about the memory management system, how these units are managed in such a way so that they can perform at their best. Then we will talk about the main memory. It is the memory that is directly connected to the CPU. That is CPU most of the time access the main memory, or it access the main memory for the current for the content that is being executed or which are under processing. Then we'll talk about the auxiliary memory, means the memory which provides us the permanent storage, which is a non-volatile type of memory. Then we will talk about associative memory, which is basically the content addressable memory. This memory is used to make the accessing of the contents fast. Then we will talk about the special type of the memory, that is the cache memory. It is the efficient and fast memory generally which is generally very close to the CPU. It is the most proximity. It is the most proximate memory to the CPU. Then we will talk about the various characteristics of the cache memory, and we will discuss about the different types of mapping techniques into the cache memory, because as we know that cache holds a small amount of data. It's a small memory because its cost is high. So the data that is to be processed by the CPU at a particular time is being fetched to this particular memory, and so we have to somehow manage the data which come to the cache memory for processing, and about the data that is to be swept back to the main memory. Then we will talk about the virtual memory. So these are the contents we will be covering in this particular unit. So in this particular slide, we will discuss about the different memories. So first memory we are discussing is the main memory, and we know that this is the memory which is used by the CPU for the direct communication. CPU communicate this memory directly. Now what does it mean by directly? Because the data which is to be processed, or the programs which is to be running, which is to be executed, will be residing in this particular memory, and CPU will be reading this data from main memory and writing back the data to the main memory. And the devices which provides the backup storage are called the auxiliary memory. We have already talked about it. We are having various types of the auxiliary memory in which we can store uh, our backup data, such as such devices generally store the non-volatile information. And the example of these types of devices are hard drive, pen drive, CD drive. These are the basically backup storage devices. We call all these devices as the auxiliary devices also. So only program and data that is to be needed by the processor resides in the main memory. As we discussed that the main memory contains all the data which is to be executed, which is to be processed. So CPU directly communicate with this memory at the runtime. And we also know all the information stored in the hard drive actually transferred to the main memory only when it is needed. What does it mean? Suppose we have 40 MB of RAM. For example, I am talking about it. 40 MB of RAM. Suppose we are having 40 MB of RAM. But somehow the program which are executing requires 100 MB of RAM. So it is sure that anyhow we will not able to load this program at a particular time into our main memory. But what we can do, we can store a small part of it. Suppose we can store 30 MB because let's suppose we are required 10 MB for the operating system purposes. So only main memory left with us is 30 MB. So what we can do, we can take the 30 MB of the process to the main memory, and remaining 70 MB will be stored into the auxiliary storage. And when this 30 MB will be finished in main memory for its execution, then we can again fetch next 30 MB to the main memory. Actually, these things doesn't go like this, but I'm talking about it because uh, I want to show that only data that is needed by the CPU at a particular time is stored in the main memory, and all remaining data is stored in auxiliary devices. Then in this slide we will discuss about the CPU registers. We have already discussed about the CPU registers. It's known as the internal processor memory. Internal processor memory, the data or the instruction has to be executed kept in these registers. We have already talked about in our previous units, and we have cache memory uh, computer system to compensate for the speed differential between the main memory access time and processor logic. Basically, it is employed between the CPU and the main memory to compensate for the speed mismatch. Then cache is used for storing segment of the program currently being executed, as we have talked about early in our lecture, that only the segments of the program that is to be executed by the CPU at the current time are stored into the cache memory, or the and temporary data frequently needed in the present calculation. The data which is required in the present calculation and the program or segment of the program that is to be executed by the CPU at a particular time is stored in this cache memory. So by making program and data available at rapid rate, it is possible to increase the performance rate of the computer. So these things we have discussed already in our previous slides. In this slide, we will talk about the memory management system. So we dig deeper what is the memory management system is. So we know that many of the operating systems are designed in such a way to support multiprogramming. We know the multiprogramming is to process the number of independent programs concurrently. We can run many programs concurrently, such as in our nowadays operating systems. We can run browser, or even many tabs of the browser, or a music player, or a word processor, or suppose we are using any editing software or making any videos, then all these programs can be executed at the same time in our computer system. So this particular thing is known as the programming. So we know that sometimes programs are too long to be accommodated in total available space available in the memory. I have discussed it in one of my earlier slides. Sometimes the program which is to be executed is larger than the total available main memory. Then what we do, we only store some part of that program into our main memory, and all the remaining part resides in the auxiliary memory. So in this type of systems, the operating system keeps tracks of the program which is to be executed and transfer this part of the program to the main memory so that it can be executed by our CPU. So uh, the part now the definition of the memory management system comes into the picture. The part of the computer system that supervise the flow of the information between the auxiliary memory and main memory is called as memory management system. So what is the memory management system? So we have to move the part of the program which is to be executed from auxiliary to main memory, and the part which is not being executed from main memory to the auxiliary memory. The part of the system which keeps tracks of all these things is known as the memory management system. In this slide we will talk about the main memory. So what is the main memory? It is basically electronic circuit based on the semiconductor integrated circuits. We talk about integrated chips in two possible operating modes. One is the static and other one is the dynamic. So what is the static RAM? RAM is basically a read access memory. So it's actually acts as a main memory in our computer system, and it uses internal flip-flops. As we know that flip-flop is a basic electronic circuit which can be used to store one bit of the data at a time. So If we organize 8 flip-flops in a fashion, then definitely it will hold 8 bit of information. And uh, these type of 8-bit flip-flop arrays, if arranged in vertical or horizontal manner, they can store. Suppose we are having the 100 these type of flip-flop arrays of 8-bit, then total amount of storage will be 100 into 8 bits. So in this fashion we'll try to design the static RAM, which is used to store the binary information. Then we will somehow arrange the capacitor. Capacitors are basically electronic devices which is used to store the charges, and the binary information is stored in these electronic capacitor in form of charges. So for 1 bit, for bit 1 there will be some specific charge, and for 0 bit there will be a specific charge. But the problem with these type of capacitor storage is that they discharge with the time. We know this property as the charge leak. So when the time passes, automatically these capacitors lose their charge. So we need to refresh, or we need to recharge these capacitor after a time gap. Means a periodic recharged or refreshing is needed in the dynamic memory, because this memory is built in using the capacitor. But due to some properties of these electronic circuits, the static RAMs are easier to use and has shorter read-write cycles. Means if you want to read some data from static RAM, or we want to write some data on the static RAM, it is easier to use. So means static RAMs are easier and faster. And dynamic RAMs means the memories which are built using the capacitors are used for the implementation of the main memory. So static RAMs are used for implementation in cache, and dynamic RAMs are basically used in implementation of the main memory. Now we will discuss about the auxiliary memories. So what are the auxiliary memories? Basically these are the permanent storage, and basically magnetic disks such as hard drive or our CD drive. These are the examples of the auxiliary memories. Tapes are also the examples. Generally, tapes were used in back in past, because most of the memories today we use in the form of the magnetic, and even the auxiliary memory is now tending to be smaller and smaller in form of SD cards. So tapes are obsolete now, but the magnetic disks such as a hard drive and CD drives, Blu-ray discs, these are currently used in our computer system for the permanent storage. Other type of storage that we use are the optical disk, magnetic drums, bubble memories. These are the also the components which are being used as an auxiliary memory in our systems. So average time required to reach a storage location in the memory and obtain its content is called the access time. So what is the access time? Suppose we want to read one word of the data, and uh, we are requiring 1 millisecond to read that data. This time is known as the access time. And suppose we are having a hard drive. We know that our hard drives are arranged, disks are arranged in a cylindrical fashions, and there are read and write heads over these disks, and combinedly all these disks are called platters. So these heads are having moving arms, they can move over the disk, and disks are rotating. So if you want to read something from the disk, then head should be on a particular track, and the particular sector should come under the head at that time when we have to start reading. So access time consists of the seek time required to position the read-write head to the location and transfer time required to transfer the data from the device. Suppose we want to read some data from uh, hard drive which is at this particular location, at this particular sector. And what will happen? First of all, the head should be moved to point to this location, and again maybe this sector is here somewhere. We have to move the disks to uh, move the disk or rotate the disk in such a way so that this particular sector comes under the head. So this time is called as the seek time. Means to point the particular location is the seek time, and then after we have to transfer that data to the particular device which is in requirement of that data. We call this whole time as the access time. So seek time required to position the read-write head to a location, and transfer time required to transfer the data to or from the device. So access time will be equal to seek time plus transfer time. So transfer time means transferring that data to the device that is in need of that data, and seek time means the head should be pointing to that particular uh, sector of the data. So this is the total access time. So this is all for today's lecture. We will be discussing the more contents of this unit in our next lectures. Thank you.